Everyone, am I audible to everyone?
Yes.
Hello. Yes. All right. So I guess few people are still joining.
Hello.
Yes, yes, Clifford. Okay, I'm just sharing my screen. Just a minute. Okay. So hello everyone. Good evening. Hope all of you are doing good. Am I audible to everyone?
Yes.
Yes.
Great. All right. So just a brief recap of the last 2 days, what we have done. We are introducing this course CCNA200-301 along with the Cisco ASA for firewall. We understood why we are doing this course, who can do this course. All right. So this was something which was discussed in the previous 2 class. So those who are new today, I'm just giving you an overview. In just 5 minutes, I'll give you a rough overview of what we did in the last 2 class. So we discussed who this course is meant for. It is meant for almost everyone who is interested to learn networking. Just the desire to learn is the prerequisite. We also discussed the fundamentals or the blueprint of the 200-301 exam, CCNA, and the topics which are included, the weightage which is given. This is available online on, you can just also go through the blueprint also. Also, this will be, all the recordings and the presentation and every kind of notes will be available into the web portal of ours, Network Journey web portal. So once you enroll, you will get all kind of recordings, notes, labs, everything. So for that, I just got an update from our team that there are only few seats left for the enrollment. So kindly do it fast by today once you're done with the lecture. So just that was an update. Then we understood the different job profiles. Once you complete this exam, we also navigated through various websites, job portals. This was the unique feature for our course, which I said most important was the practical hands-on and the assessment or the quiz, which we did last class also, and most of you enjoyed that. So today also I have one such quiz to just, understand last class what you have understood or no, things you have properly, you have assimilated and absorbed properly. This is something which is the plus or the key point of our course is we are going to give you 4 months remote lab server access. So apart from the Cisco packet tracer, which we are going to use, this lab server access is where you will actually get the feeling of, configuring the real-time devices like your switches, your routers, your firewalls. So this you will get once you enroll it. Okay, so today, just once the class is done, I should see that the seats are just, done, because I just got it to know that only few seats are left for the batch to complete. It means for the enrollment. Then I discussed the topics which we are going to cover in the lab. There are different topics from right from the scratch we are going to do it. So even there is a fresher or who doesn't know even the ABC of the networking, still that person will be able to understand what we do. So right from the packet tracer overview to all the complex topics like your VLAN, your Ether channel, your routing, everything, access list, everything will be covered. Then we have a plus combo pack along with CCNA, which is Cisco ASA Firewall. So these topics will be covered by Mr. Sagar. So he will be able to give you more important more important exposure towards the firewall topics. This was the day two topics which we started with. We understood what is bandwidth, a very important parameter when we are talking with networking. Bandwidth is a very important parameter. It is understood in terms of bits per second, kilobits per second, megabits per second, gigabits per second. So it's a very important parameter. We understood what is LAN, WAN, MAN, though we know what it is, but technically how we define it, so that we can crack the interview, we are able to say it very smooth, very fluently to the interviewer, that this is LAN, these are the characteristics of LAN, and then what is a MAN, what is a WAN. So we need to distinguish what is LAN, WAN, MAN on the basis of their characteristics and the features. Next, we also discussed about what is a public and a private network, and then we went on towards the OSI model. So this is just a reference model, we understood. This is not used by the internet. This is just a reference, a framework, a standard model, so that the different vendors who are into networking, who develop different products of networking, they get to a common standard procedure of developing their products, and there is no monopoly of anyone. So we understood there are 7 layers in this OSI model. Right from top to bottom, we have understood from application to presentation to session to transport layer, network layer, data link layer, and physical layer. At times, they are also referred in terms of layer 1, which is physical, layer 2, which is data link, layer 3, which is network, layer 4, that is transport. So many times, if they don't give you the names, you should not get confused. You should know which layer we are talking about. If I just say layer 4, that means we are talking about transport layer. So many a times during the interview or during your exams, when you are going to give your CISCO 200-301 exams, if they talk in terms of layer, you should know which layer they're talking about. So this is just a reference model, and I told you all that you have to memorize the names properly. The placement, positioning of each layer is very important. I just cannot say application and then I'd go away with transport or something in between. So the order is very important. And each and every layer carries some function, carries some role or responsibilities, and do their job better, so that there is no issue with the lower layers, that they don't have to take care of any kind of responsibility which the upper layer has to do. So there is a good compatibility between the layers. They are working, and we discussed their roles. Starting with the first 3 layers, I said that they are managed by the software. So whatever operating system we talk about, they all take care of the first 3 layers. Where the user sits on the application layer, he tries to open some application like web browser or an email or anything he wants to do, remote access, or he wants to transfer a file from a server or download a file from a server. So the user sits on the application layer, he gives his data, and that is being presented by the presentation layer in a specific format according to the specific file, whether it is a data file or a voice file or a video file. And it also takes care of the encryption and decryption, security, what I can say. And the session layer, it basically tries to maintain a separate session for individual application. So nowhere, if I open a online banking application and I also open my email application, so they will remain separated. They know from where I'm giving the request, where the reply should be landed. So which one session has to be synchronized, when the session has to expire, when it should be established, everything is taken care by the session layer. And all these 3 layers falls under the upper layer, or we say the application layers, which is managed by the softwares. We talked about the transport layer, which is the mediator, which handles the upper layers as well as the lower layers. Okay. So starting with the application layer, I'm going a little fast here because this was discussed in the last class. Okay. So still I'm trying to explain you one more time. So application layer, dealing with network applications like emails, web browsers, telnet, many more applications here we can talk about. What is this PDU? Maybe this is for the first time I am explaining. This is protocol data unit. Each layer is identified by a term where the data is meant for. Means in each layer, the data is given a specific name. So in the application layer, the data is known as data only, user data. So that term which is given to the data in each and every layer is known as the protocol data unit. So under the application layer, the protocol data unit is nothing but the user data itself. So your all your applications come into picture. Presentation, yes, as I said, it's responsible for your format, it's responsible for your syntax, semantics, encryption, compression. So you see the protocol data unit is given a term formatted data. So from the application, it was a user data. In the presentation layer, it is known as a formatted data. Coming back to the session, as I said, it is meant for holding or establishing a session, uh, trying to establish the session, close the session, maintain the session properly. So here you see that this is maintaining what you see the term simplex, half duplex, full duplex. I'll just explain it in short. So here it tries to coordinate the communication between the systems. Now, what is this full simplex, half duplex, and full duplex? Simplex is just a one-way communication. At a time, only one person can speak. Okay. Half duplex means, and simplex, you only have one channel. It is just a kind of like a radio. If you have heard about it, only there is one way of transmission. There is no kind of you are just the receivers and there are transmitters. It's a one way communication. You cannot just, the receivers cannot talk to the transmitters. So it's just there is one channel which just sends the data, and you just at the and through the same channel the receiver receives the data. We cannot send back with the same channel. So that is simplex. When I'm talking about half duplex, in the same channel, the sender and the receiver will talk with each other, but then taking their own turn. Sender will send some data, the receiver will receive it, and the receiver wants to reply something to the sender, then it will again use the same channel and send the data. But at a time, only one person can send the data through the same channel. That is your half duplex. And when we're talking about full duplex, there are two separate channels for the sender and for the receiver. So both of them can send simultaneously, or both of them, if I'm talking in terms of mobile communication, I say that both of them are talking simultaneously. We don't need to wait for the particular channel to get empty from one side and then we will speak. So this is what is half duplex, full duplex, and simplex. Okay, so for a full duplex, we have two separate channels, I can say, for sending as well as for receiving. Just a minute. Coming to the transport layer, this was very important layer which we had discussed yesterday, that it tries to segment the entire chunk of data if it is not in the permissible range. If we have to send a very big file of 2 GB, 3 GB, 50 GB, 100 GB, we cannot send it at one shot. That needs to be the data or the segments are being made. Okay, the big data is are they are breaked into some small chunks, and then only we can send the data. Now what would be the size of the chunk will depend upon the underlying transmission technology. That means if I am on the LAN, I'm using Ethernet technology, it has a predefined maximum transmission capacity, that how much of capacity this Ethernet can take the number of bytes from one part to the other part. So it is responsible for breaking the data. It once it you know that when we break the data, we should know which in sequence it has to be delivered at the receiver side. So it gives the numbers, the sequence numbers. It also looks for the reliability, whether I need an acknowledgement for what I have sent or whether I don't need an acknowledgement for what I have sent. So depending upon whether you want to have a reliable communication or an unreliable communication, we can choose TCP or UDP. TCP is a protocol in transport layer which is responsible for a reliable communication, and UDP is responsible for an unreliable communication. Also, we understood there is a flow control, which is one of the important function which transport layer looks into. That is, the sender and the receiver should be synchronized in a proper way. I need to send the data in the capacity of what the receiver can take. I just cannot send the data in the capacity which I can send. Okay. For example, the way now, if I am delivering you something and you are not under the capacity to listen to me, or I can say that I'm not sending my delivery is not according to your capacity to listen or your pace to listen, then I'm overwhelming your way of absorbing things. Okay, means you can absorb only so many words per second or so many words per minute, and I'm talking at a speed or more words in 1 minute or 1 second, then that will be overwhelming for you to understand what I'm talking. So in the similar manner, when the receiver is accepting the data, it has a specific way of accepting it. It cannot just accept the at a higher rate what the sender wants to send the data. So flow control takes care of this thing. And in transport layer, we understood that things happen end to end. That means from host A to host B, entirely the responsibility is taken care by the transport layer. The reliability and the flow control is being taken care by the transport layer, end to end. This is very important. Then the other important thing, the protocol data unit is known as segments in transport layer. Now this was not discussed in the previous class, so I'm just focusing on that. What is the data known as in a specific layer? So application layer, it's user data. Presentation layer, it is formatted data. Again, in the session layer, it was just a formatted data. In the transport layer, it comes as segments. Going to the next layer, which is layer 3, it's the heart of networking. As I mentioned, here is where your router is placed. It takes the decision of forwarding the packet when the packet arrives. It also takes a decision of calculating the shortest path from the source to the destination if there are multiple paths available. So here is where the brain of your network or your heart of the network lies. So in this case, in this layer, the information or the data is termed as packets. So when you're talking about packets, that means you're referring the network layer. With reference to each layer, an engineer is being recruited at many a times. They say they are requiring, they have a requirement for an L2 level or an L3 level or an L4 level. Okay, so if you are very well versed with the specific layer, their functions, their responsibilities, then you are being tested accordingly. So network layer responsible for logical addressing also. Here is where we'll see IP addressing, IP version 4, IP version 6, the concept of subnetting. So here logical addressing comes into picture. IP addressing is also known as logical addressing. Then comes the data link layer, which performs the physical addressing or the hardware addressing or the MAC addressing. These are all the alternate names of the same. And here the data is termed as frame. What you see in the down is a header, which has some preamble. There is a destination MAC, DMAC, that is destination MAC. SMAC, which is a source MAC. We have a data length, the data, and the frame check sequence. So here the data is termed as frame. So whatever you get in terms of your data from the network layer, that is termed as data. Okay, DATA, what you see over here, that is nothing but the network, the data received from the network layer. So it adds its own header, that is source MAC, destination MAC, and the preamble to distinguish between the two frames whenever it is transmitting. So preamble is just to indicate the start of the frame and to distinguish the next frame you want this thing. So this is also responsible for having error control. Also, it has two layers, logical link control and medium access control. So with who will access the medium when it is being shared by a lot of computers, or there is a topology. So who will share the medium first, that is being decided by this layer. So medium access is also being controlled by data link layer. And the last layer is your physical layer. Okay, sorry, the direction has been shown somewhere else. It is the physical layer where we saw that all kind of voltage, current, mechanical specifications your connectors, cables, wireless media, wire media, encoding, decoding in terms of voltage, everything is being there in the physical layer. So here, all the data now is moved in the form of zeros and ones. That means in 0 volt or 5 volt, based on what you are taking as your transmission media, whether you want to transmit in electrically or you want to take the form of light, that is optical fibers, or you want to have a wireless media, maybe through microwave or through satellite, anything. Okay, so your physical media is present in the physical layer, below the physical layer, I can say the physical, below the physical layer or in the physical layer, I can say you have the transmission media. So here the data unit is known as bits because you all have zeros and ones. To summarize, the upper layer data, that is the application presentation session layer protocol data unit, we say, or normally we say the user data or the formatted data is given to the transport layer. The data is known as segment. It adds in its own header. Now, there is a data encapsulation happening in each and every layer. Each and every layer, they add their own header in order to distinguish now that I am the transport layer, I am network layer, I am data link layer. So they add their own headers. Now, these headers basically consist of some information. Just for example, when you are putting a transport layer data encapsulation, the TCP header, it has all information related to your port numbers or your port address. It has information related to your sequences and acknowledgements. The way I said before, that it breaks the data, big data, into small chunks. So it keeps the information about sequencing, it keeps the information about acknowledgement. So all the information is being there in the TCP header. Then when it comes to the network layer, it puts its own header, that is the IP header. That means it puts its own information of source IP address, destination IP address, which kind of routing protocol you're using, which was the application protocol which was working about. All this information is there inside the IP header. More precisely, when we talk in IP header, we are interested with the source IP and destination IP at this priority. And then we can also have a lot of other information we can understand from the IP header. Coming back to the data link layer, where the data is known as frame, there are two headers which are included here. One is a logical link control and then the MAC header. There is destination MAC, source MAC, as well as the information related to who will access the medium first. All this information is given in the LLC and the MAC header. And finally, in the physical layer, things are converted into bits, what you see here, zeros and ones. So this is just a brief summary of the OSI model. This was what I was talking about: the header, source port, destination port, source IP, destination IP, the protocol. So you can see how they are being taken into the next layer. So segment is in the transport layer, so how it goes into the packet, and then the packet adds its own header, source IP, destination IP, right? And then you see the frame which adds its destination MAC, source MAC, and ether field, and then in the bits it goes like zeros and ones. So this is how you see. I'm going to give a very short quiz on this, what we have just completed, because I guess that was a good brief summary about OSI model. Now again, this is a tabular representation of the same. So if anyone has any queries on this, can ask me, because we are going to proceed with the quiz today. Yes, guys? Hello, am I audible?
Yes.
Okay, so I guess there is no questions based on this OSI model. Today I'll be showing you some hands-on and this layered approach in the how do we look these layers on practically, because this was something which was asked yesterday by one of the participant. Okay, I'm just sharing the thing on the chat box.
ARP in which layer it comes? Address resolving protocol.
Address resolution protocol will come under network layer, and I will be showing you that today.
Okay. Thank you.
Okay, yeah. Guys, just go to the chat box for today's quiz. So I hope you people will be doing it in 5 minutes. It's a very small, simple quiz.
I don't see the quiz.
You want to see the quiz? Can you find the link?
No.
Yes, yes. We are giving the quiz.
I'll just post it again. Just see in the chat box whether you're able to access. Okay, just guys, 5 minutes for this quiz, okay? It should not take much time, I feel.
Hello, I have a question, ma'am.
Yeah.
Please explain the PDU. Actually, I have joined the class late.
All right, no problem, sir.
Okay, thank you.
I'll just wait for a few minutes, 2-3 minutes, because people are giving quiz.
Okay, fine. Because I joined the class late, just briefly,
Yeah, sure. No, sir, not a
what was
problem, sir.
I complete? Fine.
Yeah, I'll just explain. Okay, 3 people have submitted the response. I'm waiting for the remaining 7, 8 students to fill it fast. Okay, 5 people have submitted. Once I get all the submissions, I will be releasing the score in just fraction of time. I hope yesterday everyone has received the correct answers for the last quiz.
May I
Okay,
ask?
guys, be quick. Very good, Kiran, if you have submitted.
Yeah, I have submitted, ma'am. I have one
Yeah,
general query.
yeah,
Not,
yeah, see.
shall I go?
Yeah, yeah, sure, sure.
Suppose I want to create one virtual machine and my host, whether we should take the host operating system Windows Server 2012 or we should go for host system Windows 10 professional.
You
Which
want to
one we
have a
should prefer? We
you
want to.
have
I want to create one virtual machine on
yeah.
my Windows 10
You
professional
can create in that
OS.
Windows. Yeah, you can do it.
So I want to ask the base operating system should be Windows 10 or Windows Server 2012
It can work on
server.
anything. It can work on anything, so it can work on your Windows 10 professional operating system also.
Okay, matlab on that I can create it.
Yeah.
So just adding on that, always the best one or the latest one is preferred. 2012 will have lot many bugs by 2020.
Okay,
So whenever you include any VM creation,
yeah.
always you will have the upgraded operating system. So 20 that Windows 10 is preferable.
On the base operating system as a
Yes,
base.
yes,
And
yes.
on guest operating system, it can be Windows 12 or 16.
Uh, yes, that can be 2012.
2012 on the guest as a guest operating system.
Yes, or you
Fine.
can also have the latest Windows Server like 2019 or 2016. So anything which is latest is preferable. No, older one will have lot of bugs and lot of features will not be working now.
Okay, on the virtual machines.
Yes.
Okay, okay. Thank you.
Okay, guys. So I guess now insufficient time was given for the quiz. So I'm just releasing the scores who have submitted. Just can check out their emails. So we'll proceed ahead. Okay. So this is a general flow how you would see a specific, like in the diagram way, how the data flow through a network. So you see an X host and a Y host. So with respect to the host X and Y, you see there are the OSI model is consisting of all the 7 layers. Yeah, I've sent the quiz result, guys, to your emails. If it has not received in your inbox, kindly check your spam. Maybe it has landed there. So I have released the score for whoever has submitted. Only 7 people have submitted the response. Okay. So moving on. So this is what I meant to say, the data flow through a network. So X host and Y host, they are sitting on their computers, logging into some applications, and this is how the flow looks. Okay, so in between you see there are a lot of routers. Okay, what you see, the symbol or circle symbol with a cross on it, that is considered to be the symbol of a router. So you see there are different paths available to reach from X to Y. So the router is taking the decision based on the routing protocol you are trying to configure there, or you want to configure a static routing. So accordingly, it configures, it takes the forwarding decision. And you see that the routers which you see in between, the router A, B, and C, okay, the flow of data, which I'm showing in the diagram, this flow, in that flow, the router does not have all the 7 layers. You should understand this, that when we are talking for a router or for a switch, up to how many layers they have, okay? They don't have all the 7 layers what we see for host X and for host Y. Okay, so this is important to understand, that we don't have all the 7 layers for everything for all the devices. As we know that router works under layer 3, it is only supposed to know the layer and its below layer. It is not supposed to know or what is there in the application and what is the transport layer doing. And as one of you asked me, what is protocol data unit, a PDU? PDU is just the way of referring a user data on a specific layer. When I'm talking in the application layer, it is known as a user data. When it comes down to the transport layer, so till the time it is in the application presentation or session layer, we can say it is a user data or a formatted user data. When it comes to the transport layer, the data is understood as segments, because now it is no more the entire data. The data has they have been divided into different segments. So we refer the data as segments. So that is what is the protocol data unit. We refer the data into a specific layer by the name protocol data unit. So under transport layer, it is known as segments. Under network layer, the same data would be understood as packets. One more thing which you have to understand here, along with the data, the headers are also being encapsulated under each layer. So the transport layer adds its own header, the packet network layer it adds its own layer. So hence the term is being changed. You cannot just say it's a user data, because we have added our own layer information along with the data received from the upper layer. So there is an encapsulation happening. The upper layer data is being taken by the lower layer. It adds its own header information, and then the total thing is known as the protocol data unit. So when you are into the network, it is understood as packets. When you are into the data link layer, it is understood as frame. And when you go into the physical layer, entirely things are converted into bits. Am I clear? Yes? Yeah, all these routers are connected via cables. There is a transmission media, they're connected by an Ethernet cable, or we can also have a serial communication between them. Okay, so now, since we already understood this functioning of each layer, what they are known as in each layer, and what are the protocols working under each layer. You can also see some examples which I have given it in the right side of the diagram. So you see over here, this is the application layer we talked about. Operating system is taking care of your sessions, the ASCII, and these are the formatting techniques or the encoding methods, I can say. Then the TCP UDP protocols, the IP protocol, these are the 802.3, the IEEE standard protocols. And then these are all your circuits, okay? V35 or EI232, these are the communication standards and circuits, what we have in the physical layer.
I think data we also have
Sorry? Okay. So there was something else again with the OSI model, that was a TCP IP. This is actually not a model, it is a protocol suite. And this was there before OSI. OSI came later, TCP IP was there from the start. and it is being used over the internet. Okay, there was one such question in the quiz that whether select one which is inappropriate about OSI model. This OSI model is not used over an internet. It's just a reference model. So TCP IP protocol suite is what we are referring when we are talking about internet. Okay, when we are talking about internet, we are talking about TCP IP protocol suite. So more or less, if I show you the structure, application, presentation, and session, these three are combined together and it is known as application in the TCP IP. Okay, so on the left part, what you see, there are 7 layers in the OSI model. Okay, there are 7 layers in the OSI model. And when we talk about the TCP IP protocol suite, we say that there are 4 to 5 layers or 5 layers for the TCP IP protocol suite. In terms of functionality, they are one and the same. So the application, presentation, and session, they are combined together in the TCP IP and they are termed as application. Transport layer is known as transport layer. The network layer is known as the internet layer or the host-to-host layer. The data link layer is known as the network access layer. And the physical layer is the physical layer. In terms of functionality, their roles, the responsibilities, whatever we have understood so far for OSI model remains the same for the TCP IP. But since it is a protocol suite, okay, as I just mentioned that it is a protocol suite, so I should be able to see some protocols under each layer. So starting with the application layer, okay, so I guess the diagram has just shifted up. Under the application layer, what you see over here, these are the different applications: TFTP, FTP, SMTP. So when you have to use file transfer, you have these other different protocols under file transfer. For email, we have SMTP. For remote login, we have Telnet, SSH. Then for network management, we have SNMP. For name management, we have DNS. So these all are the protocols which are falling inside the application layer. Since we said it is a protocol suite, okay, there was nothing first known as like a model. It has the protocols first, and then when the OSI came, it tried to distinguish all its protocol properly under a specific layer. So the protocols, you will see all about protocols in these slides. So somebody asked me ARP, that ARP is also going to come into picture. So this is your application protocols. Coming back to the transport layer, you see here, we have not discussed TCP UDP in more precise in the OSI model, but TCP UDP are the protocols under the transport layer, which we'll study in detail. Coming back to the next slide, which is the network layer. So you see your internet protocol, you see internet control message protocol, ICMP, you see address resolution protocol and reverse address resolution protocol. This ICMP, ARP, and RARP, they are known as the auxiliary protocols because the main protocol is the IP protocol, that is the internet protocol, and these are just the auxiliary types of protocol which is existing inside this layer. Okay, so I am going to demonstrate you today something in relation with ICMP and ARP. I will show you how these packets are being sent whenever we want to send a packet from one source to the host, how from the source to the receiver, how the protocols comes into picture. So we are going to see the live demonstration on Cisco Packet Tracer. So let's start with the packet tracer, I feel, and then, okay. And let me discuss first what is an ICMP and an ARP before I go to the packet tracer. Is this diagram visible to you guys? All of you are able to see this diagram? All right. So there is a switch which you see here, and you see a lot of PCs which are being connected. AAA, BBB, CCC, what you see over here, they are known as the MAC address. Okay, these are all the MAC address. And a switch has a specific port. Now a switch can have a 8 port. You can have a 8 port switch. You can have a 24 port switch. So these are the ports which you see. Though you see that they are into one line, they are actually not into one line. They are representing a specific port over here, which I will show you in the packet tracer also. So for understanding, you can just see that inside port 1, you have all these AAA, BBB, CCC, DDD. So switch is maintaining a MAC table to understand who is sitting on which port number. so that whenever it has to forward data to any specific computer, it will understand where it has to forward the data. So this port numbers and the mapping of the port numbers and the MAC address is what you have the MAC table. Now this port numbers is I'm referring to the physical ports, because at times students get confused with the different software ports which I was talking in the transport layer. That is different. Physical ports of a switch. So in port number 1 of a switch, AAA, BBB, CCC, DDD, they all are sitting. That means those computers are there over that side. Those hosts are lying over there. So MAC table is maintained by the switch in order to make a forwarding decision. That when a frame arrives, now you need to understand, switch is placed under which layer? Yes, guys. What do you think? Where is the switch placed? It's placed in the data link layer, right? So in the data link layer, we refer the data as a frame. So I will normally say that when a frame arrives or towards a switch, it checks first whether there is an entry for this specific MAC. Okay, so let's say AAA, okay, this AAA, MAC address AAA, wants to send a data to EEE, triple E. Okay, so AAA wants to send a data to triple E. So if whenever it wants to send some data, so let's say the frame arrives, okay, because now the data is being converted to proper transport layer, network layer, then it comes back to the frame, then it goes to zeros and ones, and then it goes to the zeros and 5-volt electrical signal form. So it arrives to the switch. Okay, it arrives to the switch port number 1 because AAA is sitting to the port number 1 of the switch. So when the port number, it receives the frame at port number 1, it looks into the details that, okay, you are frame coming from AAA, so you are sitting on my port number 1. Let me check you whether your entry is there in my MAC table or no. So it will not bother to check first where it wants to go. All right, it is first going to check wherever from where you are coming to my port number 1. So let me first check whether your entry is there in my table or no. And once it finds that, okay, your information is there in my MAC table, then it checks, okay, now tell me where you want to go. Now it sees that, okay, this is what the destination MAC is. Again, it goes to the refer to the MAC table and check, okay, this destination MAC, is there any entry where the destination MAC is sitting, which port number it is sitting. So it will check, okay, if there is an entry, it will say, okay, you are into my port number 2. So I will just forward your frame to port number 2. Now, how it learns the MAC table, we will learn in detail when I will be teaching you entirely. There will be one session on switch, like how the switch functions, how it works. As of now, I just want to tell you how the frame is being forwarded. So the frame forwarding decision is being taken by the switch. So before that, when AAA wants to send the data to triple E, does it knows the MAC address or it knows its IP address? If you want to send a data to any of the, like to any person who is sitting across anywhere in the globe, around the globe. So how would you know that particular address? You would know the MAC address or would you know the IP address? What would you know? Would you know the MAC address or would you know the IP address?
The IP address.
IP address. Perfect. Because if I want to speak to anybody, I should know whom I want to speak. So I would know the IP address. So let's say I want to type google.com. So basically I'm searching with an IP address first. I'm typing google.com by name, but then the name is being resolved into an IP and then the communication is happening. So whenever we want to have a communication, we should know obviously the IP address of the receiver or whoever whom I want to send the data. So the IP address is known. However, the MAC address is not known at the initial level. Okay. AAA would not know what is the MAC address of the PC EEE. Okay, it may know the IP address. Let's say that this is IP 10.0.0.1/8, and this is, let's say, 10.0.0.10/8. So it will know that this is my source IP and whom I want to speak to. This is my destination IP. I know what is my source MAC because it is there in my MAC NI network interface card. Okay, I know who am I. I know my MAC address, which is AAA. But then when I want to send a data, I know that the data is made up of something like there is a data, and then you have a data link layer information, and then here you have your network layer information where you put the source IP, the destination IP. We have the source MAC, the destination MAC. Now we know the source IP, we know the destination IP, we know the source MAC. What we don't know is the destination MAC. Okay, so initially we would not know what is the destination MAC. So we need to learn this. Okay, so in order to learn this, we have this ARP, which is your address resolution protocol. So this is a table. There is an ARP table which will be there in each of our PCs. We have an ARP table. We just need to type a command ARP space -A, and we will get the list of all the entries. Like this is the IP, this was the MAC, this is the IP, this is the MAC. So we will get entirely the table in our computer. We can just go to the command prompt of our computer and just type ARP space -A. I will show you that, don't worry. So once I do that, I get the table. So initially there was no such table. Initially the table was empty, 10.0.0.10. There was no MAC which I was knowing. So there was no MAC which was known to me because I have not learned the MAC address. So ARP packet or ARP protocol helps you getting the MAC address. So what happens now, since I have to anyways learn the data, it will put a broadcast address. So it will put FFFFF, because when you are looking with the MAC, we need to understand it use hexadecimal approach. The way we have source IP, destination IP, IP is using a decimal dotted notation. You see there is a decimal number and there is a dotted representation. So your IP is a decimal dotted notation, and your MAC, which you're using, hardware address, is a hexadecimal notation. And I don't know how many of you, the number systems, we have decimal, hexadecimal, binary, octal. These are the different number systems which we have. So MAC address, I will come to it. You don't have to worry, because step by step, again, we are going to go in a very detailed manner. We are going to learn MAC address and all these things. So it is in hexadecimal. So hexadecimal, there is a letter F, which stands for 15 value. And we say that it is a broadcast value. Okay, so we give all the letters to be FFF, so as the switch understands that this is a broadcast frame. Okay, so when the frame arrives to the switch, the first question the switch asks to itself, who is this? So it says that, okay, this is MAC address AAA sitting into my port number 1. Let me check whether this entry is there in my table. If it is not there in my table, let me write your entry first, that on my port number 1, AAA is sitting. Then it checks next, okay, where you want to go now? Okay, then it understands this is the destination MAC. So that means I need to give it to everyone who is sitting into all my ports. I need to broadcast it because it's a broadcast frame. It identifies that it's a broadcast frame. That means it has to forward to all the ports. So as of now, guys, can you mute?
அவன் நடிக்கிறான்ப்பா. அவன் ஏந்திரிக்கிறப்ப இது பண்ணிட்டு தான் இருக்கான். இப்போ விளையாடுங்க. அடி போடுறா ஃபர்ஸ்ட். அடி பிச்சிரும் பிச்சு நிக்கலாம். விளையாடுறீங்க. போடு ஃபர்ஸ்ட். விளையாடுறது உனக்கு அவ்வளவுதான் இருக்கு அவனுக்கு.
Hello. Sagar, can you mute? Yeah. So I was talking about that since it receives a broadcast frame with the destination MAC address FFF, so the switch understands that, okay, I need to forward this frame to everyone. Okay, so it will forward it to all the ports, whichever ports he has. Here you see there are 4 ports, so it will send it to everyone. But after it sends it to everyone, everyone will accept the frame, because everyone understands that if something is coming as a broadcast, then I have to anyways accept. And if something is coming to individually as unicast, then again I have to accept. There are 3 types of communication here. We have a unicast, we have a multicast, and then we have a broadcast. So when you listen a radio, it's a broadcast. Now, when you're listening to me, you are a group of people, it's a multicast group. And if I'm speaking to only one specific individual from you, I'm doing a unicast. So when the switch broadcasts all the frames to all the ports, everyone sitting on the port will receive the frame and it will say, okay, it is a broadcast, so I have to accept it. Then it tries to, tries to decapsulate. Means it tries to, since it receives on the physical layer, then from physical layer, it goes towards the data link layer. From the data link layer, it understands that it is a broadcast message. So then it tries to open up the next layer and check the network layer. And then it says, boop, it's not for me. Let me discard. Okay. So this is how all other PCs are going to discard the packet except this PC, because it will understand that when it opens its network layer, it will understand that this has come for me, and it will understand from the message that it was an ARP request. Somebody is requesting my MAC address, so let me reply my MAC to that person. So again, it will try to create its own frame with saying that this is the reply of my, so let's say there is a message written that here is my MAC. So it's sending the reply with the source MAC, with its own MAC now, and destination MAC. Since now it has received the frame, it knows who is the destination. So it will put AAA, then the source IP is its own IP, and then the destination IP is .1. Okay. So again, now it sends a reply. The switch is again accepting the frame, asking, who are you first? Then it checks the destination MAC, again goes and refer to the MAC table. Are you there in MAC table? If you're not there, let me write your entry that you're sitting in the port number second of mine. And then it checks where you want to go. You want to go to AAA. Let me check my table again. Okay, this entry is in port number 1. So now I'll forward it to the port number 1, and AAA will receive the frame. And in this manner, it will update in its ARP table that 10.0.0.10 is having a MAC address EEE. So next time, whenever he has to send the data, it will put properly the data EEE into the destination MAC, and then the switch will also not broadcast it, switch will forward it to the relevant port. So this is how ARP helps mapping the logical address with the physical address. So let me show you quickly with the packet tracer, the demonstration. You'll enjoy it. So here is this packet tracer. Everyone is able to view. Are you able to see the packet tracer?
Yeah, we can see it.
Yeah. And don't you worry, because I will show you the step-by-step installation of this packet tracer, and also you will be able to access the remote lab server. The only thing we are waiting is for the complete enrollment, and we'll be starting full-fledged from day number 6, and I'll explain you all the steps of installation and everything. How to access the remote server, how to download the softwares, how to, access the web portal for the recordings. Everything will be explained to those who enroll for the course. So it's hurry up, guys. You have to do it quickly. So let's place a computer. So there's a computer here, which you see, end device. And there's a network device, which I'm taking from here. I want to pick a switch. So I'm taking a switch here. And it's just a drag and drop case. Okay, this is the workspace where you will be taking the components from here and just dropping here. And let me take one more computer. I'll take one more computer over here. Okay. So this is like a normal computer, what we use it. So when you go inside your computer, you will see there are a lot of things inside this. I'll explain you this later. Coming back to the IP configuration, I have to give an IP over here. So I will give an IP over here. Let's say 10.0.0.1. And it will take its subnet mask on its own. Since we have not learned about what is an IP address, what are the different classes, I'll just keep it likewise. I'll just close it. So it is 10.0.0.1. Same way, I'll give this another IP, 10.0.0.2, and let it have its own mask. And let this be 10.0.0.3. Now, since I've not connected anybody, I have to connect, right? So there's a cable connection. You can see this zigzag. Okay, just take it, go to the PC, and then go towards the switch. And it will ask, it will connect from the fast Ethernet port number 0. Now, I was talking about port numbers. When you go inside the switch, when you double click on the switch, you have to go to the config mode or the config tab. And you will see this fast Ethernet 0/1, 0/2, 0/3, 0/4. Likewise, you will see there are 24 ports of fast Ethernet and 2 ports of gigabit Ethernet. So this is how you see the port numbers, the way I was discussing just right now, port numbers. So these are the ports of the switches. They are known as interfaces, or we can also say these are the switch ports. So since now I'm connecting only 3 computers, so it will by default take the first port, and then again I'll take this connection, go to this PC, and then connect it. Again, take the connection, go to this PC, and connect. What I've done just now, I've just taken one switch and I've just connected 3 computers to it. I've given 3 IP addresses. Okay. So let me just write here which IP address I've just given here. I've given here 10.0.0.1/8. Here I have given 10.0.0.2/8. And here I have given 10.0.0.3/8. Now, since nobody knows over here, right? You can go and check into the PC, go to the command prompt, the way we have our command prompt. Same in the similar manner, there is a command prompt into the PC. I can go and check through IP config the way we can do it in our command prompt. I just do IP config. So you can see there is a Ethernet or this particular adapter. It has a MAC address. Okay, can you see the MAC address, guys? There is an IPv4 address 10.0.0.1 with the subnet mask. So IP config, the way we used to do IP config, in the similar manner we are doing it here. And let me check my ARP entry. So I just need to type ARP space -A and I'll just enter. So initially you see that there is no ARP entries found over here. Okay, so there are no entries which has been found. Every PC will have the same thing. You can go and just check for ARP. Just go to the PC, the command prompt, ARP-A. So there are no ARP entries at the very start when we are connecting the computers just to the switch. Now, how would we understand how the ARP request and the reply is going on? So inside this, what I'm going to do is, okay, I am going to go to the simulation mode. There are 2 modes inside the packet tracer. Whatever I was just doing here in the real time, I was just trying to drag the component, place it, and then configure it. Okay, that's it. And I did nothing. Okay, now I will go to the simulation mode. Just go to the simulation mode. And there will be a panel coming up here, which will show you how the frames or the packets are coming from which direction, then it is sent to which one, and then how the request is coming. The way I just explained you we will be able to see this properly. So what I will do now, I'll go to the PC, I'll go to the command prompt, and I'll try to ping. What is ping? I'll tell you. I'll just ping 10.0.0.2 because my address is 10.0.0.1. I'll be putting the address of whoever I want to speak. Okay, so 10.0.0.2, and I'll just put enter, and I'll minimize this so that you will be able to see this packet. Okay, there are two packets which you see. One is the ARP packet and the other one is the ICMP packet. These two protocols, just now what I showed you in the presentation, that these are the auxiliary protocols inside the network layer. So as soon as I said ping 10.0.0.2, which was the IP of this PC4, okay, you can see that PC3 is from where I'm sending the ping, and PC4 will have to reply to the ping. But when the frame will reach to the switch, okay, let me just play for you. So now when I'm just asking for a ping, means I'm creating an ICMP packet. Also an ARP packet is simultaneously created because 10.0.0.1 PC3 doesn't know the MAC address of PC4. So before it pings, it also has to start the ARP request because it wants to learn the MAC. So both the packets you can see is being created simultaneously. Now what I'll do, I'll just play next so that you will know how the packets are traversing the network. So you see from here, the ARP packet has first gone. So though the ICMP and ARP both were created together, but when it understood that there is no MAC, which I know, so how would I just go and create an ICMP packet? How would I check the connectivity or check the network layer status of PC4? Ping is basically to check the network layer status of the recipient or whoever I want to connect with. It is basically to check the network layer status. Most of the time we say ping is used to check the connectivity. It is not to check the connectivity. It is to check the network layer status of the recipient or of the receiver's PC, whether it is ready for communication. So ICMP packet, you can see that it has not seen now. Only the ARP packet is going to the switch 3. You can see here from the start, I will just click on this. When this packet was made, I can just go and click on this. When I click on this, I see the OSI model, the in layer and the out layer. The out layer, this is at PC3 from where I'm initiating the ping. So layer 1 and layer 2, because I am only having this information, that you can see that this 0002.170.8EEB, this is my source MAC address. All the 4 Fs, what you see, that is the broadcast address which I was talking about. ARP is the type of protocol which is running. The source IP is 10.0.0.1 and the destination IP is 10.0.0.2. So as soon as this ping was started in the PC3, okay, I'm referring that name as PC3 because it's taking as PC3. So this frame layer 1 and layer 2 information is ready. Okay. Now when it comes to switch, you can just go and check it out. So in and out. So what it receives and then what it will send. That is the information. So when it receives at layer 1, it sees that this is the MAC address with the broadcast MAC address and the source IP and the destination IP. Then it will forward the same. So this is in means it is receiving from PC3 and this is going to be out from the switch to the next. Okay. So it will be out so the out layer is basically talking about what the switch will forward to the other ports. So again, it was going to forward, this is the source, this is the broadcast message, this is the source IP, this is the destination IP. You can also check how it works physically. It is telling you when you go here, you will see step by step, everything is being mentioned here. The frame source MAC address does not exist in the MAC table of the switch. So switch adds a new MAC entry in its table. So that is what first it is doing. Just as I said, that whenever it comes, it does not look where it has to go first. It looks from where you have come. Let me check whether your entry is there in my table. Then the frame destination MAC address is broadcast. So the switch processes the frame. The frame destination MAC address matches the receiving port's MAC address, then the broadcast address or a multicast address. The device encapsulates the PDU from the Ethernet frame. The frame is an ARP frame. The ARP processes it. The active VLAN interface is not up, and the ARP process ignores the frame. VLAN we will be taking up later. So this is a broadcast frame. The switch sends out the frame to all of its ports in the same VLAN except the receiving port. Obviously, those from where it comes, it will not send it to the same port again while broadcasting. So this is what is happening next. Okay, and then it sends the frame to fast Ethernet 0/2 and 0/3. So whichever ports now, since there are in two ports, these two devices are connected, 0/2 and 0/3. So since it's a broadcast message, it will forward it to all the other ports. And then let us check what happens next. So now when I press next, the frame will go to both the ports 0/2 and 0/3. Okay, so let me just play this. So as per our information, you can see who is discarding it. There is a cross sign which is coming up from PC number 5 because it is discarding the packet. Okay, it was not meant for 10.0.0.3, so it will discard that ARP packet. Okay, so PC5 will discard it. PC4 has accepted it. You can just go and check out. Just go into the PC5, which is the PC which is discarding it. So you can go and click there. It receives the frame, and then you can see that the frame destination MAC address matches the receiving port since it's a broadcast. It decapsulates the PDU from the Ethernet frame. And the frame is an ARP frame, so it processes it. The frame is a request because ARP request is happening. And then you see that the ARP process drops the frame because it is not matching with the receiving port's IP address. So it is going to drop it. And then PC4, for which it was meant for, that one, if you see, you will see it has accepted the information. Okay, so the ARP requests the target IP address, matches the receiver's port IP address, and it updates the ARP table with the received information. So once it receives the request, it is also updating its own ARP table. Okay, so automatically you will see that the ARP table of this PC will also get updated. And now we will see what happens next. What should happen next, guys? What should happen next?
PC4 respond back.
Exactly. So the PC4 will have to reply to the request. So let me just play for it. So you see the reply has gone to the switch now. So the switch, you can see from here, the switch will look into the MAC table first and enter a new entry in its table because first it will see who has come, to which port it has come. And now since it's a unicast frame, it looks into the MAC table for the destination MAC address. Okay, switch is a very intelligent device, unlike hub. Okay, so when it knows which port number the specific MAC is sitting, so it will just forward it into the relevant port. So this is how you see here. Now when I again press next, the reply has come. That means the first reply has come. ICMP has also started now. You can see from here, the ICMP request is now active because the ARP request has been come. Okay. Now if I just go and press next, now the ICMP will start. Okay. You can see here the ICMP process has started because the ARP has completed, the ARP process has been completed. So now the ICMP has started. Now when I put the ICMP, so next it will go to the switch. Okay. Now the switch will forward it to the relevant port. It will not broadcast now because it will just forward. It has learned from its MAC table where the PC4 is sitting, which port it is sitting. So it will just forward it to PC4 and not PC5. So next you see, it goes to the PC4. Now from this, you will see that it will get a reply. It will send again a reply. So all this information, what we have learned in the layer-wise OSI model, inbound, outbound details, PDU details, we will check out later. These are the header information. Okay. This will give more details like source IP, destination IP, which protocol is working. Okay. All information. This is an ICMP protocol with type 8. Type 8 means there is a ping request which is happening. Okay. Every type or every number has a specific meaning or a message. So type 00x8, what you see here, it's a ping request which is coming up. Okay. And outbound details, again, you can see outbound means what it will send now. Since I'm on PC4, inbound was something which it has received. Okay. Inbound means what it receives, and outbound means now what it will send. So in the outbound, it is going to send type as 0x00, this ICMP, which means it's a ARP reply. Okay. Sorry, ICMP reply, the ping reply. This was the ping request, and this is now what it will send when it has to send. So now again, let's go and play it. So I'll just forward it. Now again, it goes to the switch, and from the switch, again, you can see from your switch will now have a proper MAC address into its the frame will have the proper details. So you see this again, type 0, that means the reply is going. Okay. And then again, when I press next, the first reply has come. Now let me just open this PC. So you will see that the first reply has now come because ICMP request and the first packet. So totally 4 packets would be sent whenever I do ping. Okay. 4 packets are just sent to check the network layer status. So the first reply, we have got it. Again, what will happen now? 3 times the same process will happen. Okay. So 3 times, if you just see, again, I'll just forward it. Next, it will send it to the switch again. It will come back to the PC4. It will again give a reply, and it will again come to the PC3. So this would be my second reply. Let me just open it. So you see that the first reply has now come. Okay. And then again, if you just see,
I'm not getting any audio.
Hello, ma'am. Hello.
hello, hello.
Ah, yes, ma'am.
So sorry, there was some issue, I guess, from my internet side. Yeah.
Okay, ma'am. No problem. Okay.
Okay. So I was just discussing the same. So this was my second ICMP. The third ICMP, which was the ICMP reply. So this is now what it will send. Extremely sorry, guys. I don't know what was the issue. Hello.
Hello.
Yeah.
Okay.
So sorry for that. So this is how now when I check the ARP entry in my this table in my computer, ARP-A. So now you see this address of 10002 and its physical address is now can be reflected. It can be reflected into the ARP table. Similarly, you will go and check for this PC4. Okay. Even in this, if you go to the command prompt, and since initially there were no ARP entries, now if you just go and type the same thing, you will find that it has also updated its ARP table. Okay. So in this manner, the ARP request and the reply is happening. Whenever it doesn't know the MAC address, the ARP protocol helps resolving the addresses. Yes, guys, is this clear? So I hope you have completely understood the topic of ARP, how the ARP things work, and I wish that you all enroll today itself after the class. So we have understood what is OSI model, how the layers work. We also understood what is TCP/IP protocol suite, and we have seen one demonstration on Cisco Packet Tracer, how the ARP request and the reply works. So if anyone has any queries or any doubts, we can go ahead. For the pricing of this course, kindly contact Sagar or Abdul. They will brief you out with the course fee structure. And as I already told you that we are going to give you an access for remote lab server, access of that for 4 months, as well as I will be showing you how to download the packet tracer file, the Wireshark files, and other kinds of simulators or emulators that we will be showing up once you enroll, once the enrollment is done. So do it fast since we have limited seats left. Yes, guys. Any queries regarding today's session or topic?
There's something called GARP. Where does that fit in the TCP/IP stack?
Sorry?
GARP.
You're talking about RARP?
No, GARP, gratuitous ARP or something they call it.
I'm not able to hear you clearly.
I'm sorry, can you hear me now?
Yeah, say.
Yeah, so it's GARP, like gratuitous ARP or something?
GARP you're talking about?
Yeah, something, yeah.
I'll get back to you about this because...
That's fine. Yeah, I don't need the answer right now. And then what about MPLS? Is that between the two layers?
Sorry, between the two layers?
MPLS?
LC?
MPLS.
MPLS. Okay, the label switching. That is basically when you will be, when we will be learning about VPN and all. That time I will be able to show you about MPLS. It's a label, like it's a kind of, we have a different types of switching, circuit switching, packet switching and all. So when we are talking in terms of label, that's a labeling thing. So there we have a MPLS. So when we will discuss about VPN and all, there we will discuss about MPLS.
Okay, thank you.
Yeah.
What is RARP protocol?
It's a reverse reply, sir. Reverse address resolution protocol. What you see in the request and what you get a reply for the ARP, that is what is the thing we talk about. That means if you know the logical address, you will be able to get the MAC address, and from the MAC also you can, means from the table you can see both logical as well as the MAC address MAC address information.
You mean to say that from MAC address we can able to know logical address?
No, it's a mapping of the table. The table from where, if I know, if I have to find which IP, if I have the table with me, if I know the logical address from the table, I can get the MAC address. And if I know the MAC address from the table also, I can point out which is the IP address.
It means mapping is called RARP.
Yeah, yeah. Since the table has both the entries, so if you can see the MAC, you can also find out what is the IP for that.
Yeah, yeah.
Any other queries? Did you all enjoyed the simulation which I was showing you all?
ये क्या कर रही है ये जोर से मारा इसने उस पे अंगूठे पे इसको उधर करो.
Hello. Okay, guys. So enroll it fast. I want to see you all into the actual course, doing the same stuff, and I will be giving you some assignments in the packet tracer files to troubleshoot or to configure. So that will be more fun. Okay. So see you tomorrow with with the new topic, with some new simulation and some new quizzes. So if there is no question, we'll end the session. Have a great day. Good night.
हेलो.
Yeah.
हेलो. मैम इसकी मुझे फुल लिंक मिल सकती है क्या इसकी, इस वीडियो की?
Yeah, you will get it, but I guess for this recording you are asking?
No, ma'am. I do not record for this video. So please send your link, ma'am.
No, link. I'm telling you the recordings will be available to you.
Tomorrow 12 p.m. ma'am.
Exactly, I'm not getting your question. You want the recordings, right?
One second.
Hello.
Yeah.
Hello.
From where we have to download this packet tracer and Wireshark?
Sir, I'll explain that thing. I guess we have this 5-day free trial, so I'm explaining you the theoretical concepts and the online simulation. The simulation part, I'm explaining you. Once you enroll it, you will get all the information about downloading the packet tracer file, the Wireshark files, accessing the remote server, and how to access our web portal for the recordings, notes, assignments. Everything will be given once you enroll.
Okay.
So you have to contact Sagar and Abdul for the enrollment of the course, which is already started, and in full-fledged we are going to start again, means from day number 6. All and each and everything from scratch of how to download the software, how to use it, everything you will be given, all support, how to access the lab, everything will be shown to you. So you can contact Sagar for more information about the pricing. Thank you, Harshal, for your feedback.
Yes, ma'am. Yes, ma'am. Thank you.
Thank you. Bye-bye.
Bye-bye, ma'am. Good night.
Good night.
Have a nice night.
You too. So I guess there are no more questions from your end. So we'll end it.